The headline, "Your AI usage is breaking your system design," triggers a specific cognitive shift. Viewers initially interpret usage spikes as a billing panic or a credit card issue. The hook must immediately reframe this anxiety, not as an accounting problem, but as a hard engineering constraint. When your tokens burn faster than you can cache them, you have hit the physical limits of inference hardware and queuing theory. This is about why their architecture failed to handle high-throughput workloads before they even looked at a bill. When developers see their monthly allowance vanish in hours, the first instinct is usually financial panic. They assume they simply need more budget or a better pricing plan. But that reaction misses the fundamental truth of modern AI engineering. Your usage quota is not just a billing metric, it is a real-time reflection of your system's ability to handle hardware inference limits and queuing dynamics. If you are burning through 3% of your monthly allowance in a single morning, you have not just spent money. You have hit the physical throughput ceiling of the model because your architecture lacks caching or batching guardrails. This shift from seat-based subscriptions to usage-based billing exposes the hard truth. Your token budget is actually your latency and throughput constraint. If you do not architect around it, your system collapses regardless of how much money you have. Recent data regarding GitHub Copilot's transition to a strict usage model, effective June 1, 2026, reveals that credits are no longer abstract currency but direct proxies for finite hardware inference capacity. When users exhaust allowances in days rather than months, it indicates a systemic failure to manage concurrency, batching, and caching within their own workflows. The reality of the current landscape shows us that agentic workflows consume orders of magnitude more resources than simple autocomplete because they trigger complex inference chains without architectural guardrails. We have seen specific cases where students burn through 200 credits on a single agent mode session, or professionals deplete pro-level plans in less than 48 hours. These are not anomalies caused by bad luck. They are symptoms of unmanaged data pipelines amplifying errors when hardware limits are ignored, turning minor coding artifacts into systemic failures that overwhelm the inference queue instantly. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Consider the difference between traditional completion and modern agentic behavior. A simple autocomplete request is a direct hit to an engine, requiring minimal context retrieval. However, in agentic workflows, a single interaction can trigger complex multi-step reasoning chains that saturate server queues immediately. Without architectural design patterns to manage this flow, high-throughput workloads become immediate system failures for the user and bottlenecks for the provider. The transition from seat-based subscriptions highlights this shift perfectly, as we now see 3 out of 7 proposed design patterns having partial precedence in existing systems, while 4 remaining patterns are presented as novel formal descriptions without prior literature to guide developers on how to handle these spikes safely. The core issue is that your system design likely treats AI requests like database queries or HTTP calls, where you assume infinite elasticity and instant response times. In reality, every token generated requires physical computation time on a GPU or TPU cluster subject to queuing theory constraints. When you send 10 requests simultaneously without batching them into efficient inference batches, you are effectively overwhelming the hardware's ability to process them in parallel. This creates a backlog where each subsequent request waits longer than the last, causing your application latency to spike and your token consumption to balloon. As retries occur or context windows expand unnecessarily due to timeout loops. To solve this, we must stop viewing usage quotas as financial limits and start treating them as architectural constraints that dictate how our software behaves under load. The solution is not buying more credits, but implementing design patterns like asynchronous processing, sufficient response caching for repeated queries, and request queuing before hitting the hardware layer. By redesigning workflows to include local LLMs for simple tasks, or using ontological checkpoints where we validate if a complex inference is truly necessary before sending it, you can flatten the spike in hardware demand significantly. These patterns ensure that the system handles high-throughput loads efficiently without overwhelming the inference queue and triggering reification loops that turn minor artifacts into catastrophic failures. The study identifies 3 competing forces shaping this clinical data perspective: clinical necessity for accuracy, administrative requirements for cost control, and institutional incentives to adopt new tools rapidly. Balancing these requires a shift in how engineers approach system design. We must prioritize the physical reality of inference engines over the abstract convenience of API calls. When you burn through 200 credits in one morning with agent mode enabled, it is not just an accounting error. It is evidence that your concurrency model has failed to respect the queuing dynamics of the underlying hardware. In agentic workflows, a single interaction can trigger complex inference chains that saturate server queues instantly. Without architectural design patterns to manage this flow, high-throughput workloads become immediate system failures. This means every new feature request leads to an immediate credit overage or service halt if you have not built the necessary buffers into your codebase. The engineering insight is that running out of credits is actually a symptom of poor system design, specifically, the lack of asynchronous processing and failure to batch inference requests before they hit the hardware layer. We must recognize that in an AI-native world, token consumption is directly tied to latency and throughput constraints rather than just financial expenditure. If you do not architect around these physical limits, your system collapses regardless of how much money you have available for billing. This requires a fundamental change in judgment from developers who want the latest capabilities without understanding the cost structure imposed by hardware physics. By adopting strategies that manage concurrency and caching effectively, we can build systems that are resilient to spikes in demand rather than brittle ones that break under pressure. The transition announced on April 17, 2026, marks a turning point where usage-based billing becomes the standard for all professional tiers. This forces engineers to confront the reality that their code is not just logic, but also a requester of physical resources with finite capacity. The implementation deadline of June 1st requires teams to audit their workflows immediately to ensure they are not inadvertently creating bottlenecks that waste expensive compute cycles on redundant or poorly structured queries. When you understand that usage quotas reflect your system's ability to handle hardware inference limits, the panic subsides and engineering rigor takes over. You stop asking for more budget and start optimizing your code. This shifts the viewer from a passive consumer of tokens to an architect managing hardware throughput with intention and precision. The goal is not just to save money, but to build systems that are robust against the physical constraints of modern AI infrastructure, ensuring reliability even as usage scales rapidly across the organization. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.